Welcome to the module on soil properties. The learning objectives for this unit are as follows. First, you'll be able to understand the makeup of soil and its basic properties that are relevant to bridge design. Second, you'll learn how to classify soil at a high level. And third, you'll understand the vocabulary we use to discuss soil from an engineering perspective. In this first video, I will discuss density and unit weight. It's important to note that we will be using density, which is mass over volume, sometimes interchangeably with unit weight, which is going to be force over volume. Because we have standard gravity on Earth, this conversion will always be made with the factor for gravitational acceleration. We just need to make sure that the units of the final answer are correct. For example, we don't want to be comparing kilograms with kilonewtons directly. We'll have to be converting using gravitational acceleration. So at its basic level, soil consists of air, water, and solids. The varying content of these items will affect the unit weight of the entire soil mass. And as you've learned from previous lectures, unit weight significantly affects the global sliding and uplifting of our abutment structures. The graphic here shows how these properties are related. These equations are summarized in the attached Civil Engineering Reference Handbook under section 3.8.3. And given various properties of a soil sample, we can use the equations there to calculate its dry, moist, or saturated unit weight. Air in soil is weightless. The volume of air contributes to the total volume of voids. And in the case of saturated soils, the entire volume of air has been replaced with water. Water in soil fills the voids and has a weight component. Saturated soil has its voids completely filled with water, and moist or wet soil partially fills these voids and shares the rest with air. Dry soil obviously will have no water, or a very small water content. Solids in soil is the main weight component. Be careful not to confuse this with the amount of water, which also holds a component of weight. So the amount of voids, type of voids, and flow of water through these voids depends on the type of solids that we have. Later in the course, we will discuss specifically the solid portion of the soil, which can be sandy, gravelly, clayey, silty, etc. The standard starting point for the density of EIA soils is 1,800 kilograms per meter cubed. Additional soil testing information can help us sharpen the pencil on this value, but in the absence of this testing, or the ability to correlate certain soil properties to make a better estimate for soil density, 1,800 kilograms per cubic meter is a conservative estimate. And throughout the rest of these lectures, I'll refer to EIA soil, and this is just going to be what our starting point for our assumptions is going to be, the default value, if you will, unless we have other information to point us in a different direction.